Hello, my dear students. Now, welcome to the course on design and analysis of algorithms. So, first, let us start with the introduction session. First, let me introduce myself. My name is Professor Shailendra Kumar Sonkar. I'm working as an assistant professor in Department of Information Technology, University College of Engineering and Technology, Vinoba Bhave University, Hazaribagh, Jharkhand. So let us moving ahead. These are the outlines of my today lectures. So first, we will start with the expectation or prerequisites of this particular course, then moving ahead with focusing on course outlines, then moving forward we will discuss about course outcomes, then we we will start with the introduction session of this particular course and moving ahead with a little bit uh, focus on the properties of the algorithm, then moving forward to the focusing on the analyzing of an algorithm, then moving ahead with the focusing on asymptotic notation of the algorithms, then we will discuss about the recurrence relation, then how we solve these recurrence relations, and finally we will wind up with the basic approaches of the algorithms. So we can move forward. So first, I tell you the prerequisites or expectation of this particular course. So first is the student proficient in mm, basic background of mathematics knowledge. You should be aware of the basic knowledge of recurrence relations, series, and some mathematical equations. Uh, and we need also some programming background. So we should aware of any programming language like C, C++, Java, and nowadays we are a very popular programming language. It's a Python, and as well as you should aware of the basic knowledge of the data structure. You should aware of the basic concepts of arrays, stack, queue, and lists. So all these are the prerequisites of this particular course. So next, I'm focusing on the course outlines. So basically it's a 3 credit course and we have assigned with the 3 lectures, 1 tutorial and 1 practical sessions per week. It contains 5 modules, and in the first module we will discuss about the introduction and analysis. In the second module we will discuss about the divide and conquer and backtracking approach. In the third module, we are focusing on greedy paradigm and dynamic programming. In the fourth module, we will discuss about the graph and string matching algorithm. And in the last module, we will discussing about the NP complete problems. Now, I tell you the assessment and evaluation criteria for this course. So it's a 100 marks course, and this 100 marks is breakdown in 2 parts. 70 marks for your external evaluation, and this will be assessed by the university exams, and 30 marks for your internal evaluations, which is uh, uh, which assigned through the continuous evaluations. So Again, this 30 marks is breakdown in two parts: 10 marks for your mid-sem examination and 20 marks for teacher assessment. So these 20 marks is uh, from my side, and uh, uh, and these 20 marks again break down into three parts: 10 marks for your assignments, and I'm giving total 5 assignments, one assignment per modules, and 5 marks for quizzes, and I'm giving total 5 quizzes, one quiz per module, and last is 5 marks for attendance. So it is very clear to all of you, if a student secured more than 90% attendance, then I will simply assign the 5 marks. If a student secured more than 80% but less than 90% attendance, then I will simply assign the 4 marks. And if a student secured less than 80% attendance but greater than the 75%, which is the threshold or the deadline of the attendance. So I will simply assign the 3 marks. And if a student secured less than 75%, I will simply assign 0 marks. So this is clear to all of you. So I'm moving ahead. So next, I tell you the course outcome. So after completing this course, the student will be able to analyze the performance of the algorithm. The student will be able to choose appropriate algorithm design techniques for solving problems, and the student also able to understand how the choice of data structures and algorithm design methods impact the performance of the programs. Again, we are moving forward. So let us start with the introduction sessions on the algorithm. So as you know, uh, each and every problems, it may be simple problem, it may be complex problem, it may be too complex problem. So each and every problem we need to write the proper algorithm, so that uh, we are able to solve the given problem in easily and conventional manner. So by using algorithm, we can solve uh, all complex, all simple type problems. So first thing is comes our mind, what is an algorithm? So this is the definition of the algorithm which is given in the Corman book. So it is defined as well-defined computational procedures that take some value or set of values as input and produces some value or set of values as outputs. So eh, you can simply say that algorithm is a sequence of computational steps that transform the input into the output. So as you can see in the figure number 1, this is the notion of the algorithm. So first we need to identify a problem, or we have a given problems. So for this problem, we need to write the proper algorithms. So by uh, writing the proper algorithm, we need to convert this algorithm into programs by using any programming language like C, C++, Java, or nowadays we are using the Python. So again, this program is given to the any computer, any machines, and this program is executed by using this machine and uh, provides the required input this machine after execution of the program will simply give the uh, output as a result. So the result or output, it may be correct or it may be incorrect. If it is correct, then it is fine. Otherwise, we need to backward to the algorithm portion of the given problem, and we need to modify and remove all the deficiency or error in the given algorithm, and again proceed in the similar manner. So let us moving to I tell you one more thing. An algorithm is represented uh, as in pseudocode form, or you can write down using simple English language, or you can represent in a graphical format like the flowchart method. So these are the various these all these are the representation of the algorithms. So but as a computer science or IT student, we will prefer the pseudocode form. So next is these are the basic properties of the algorithm. So first property is the non-ambiguity. Non-ambiguity, it means each instruction should be clear and precise, and it should not denote any conflicting meaning. Second is the range of input. The range of input must be specified. Otherwise, the algorithm may be go in an infinite state. Next is the multiplicity. Multiplicity means the same algorithm can be represented in many ways. Uh, Let us take an example of the searching of a particular element in a given sequence of element. So you can search the particular element by using the sequential search approach or by using binary search approach. The approach or method is different, but the result will be same. Last one is finiteness. It means after performing the required task, algorithm must be terminate. Uh, Again, uh, we will move to the next part of the lectures. So next is the analyzing algorithm. So uh, analysis of algorithm means it simply predicting the resources required by the given algorithm. It may be in terms of the time, or it may be in terms of the storage. So amount of time required by algorithm, it simply terms as the time complexity of the given problem, and the amount of storage required by algorithm, it simply termed as the space complexity of the given algorithm. Now, what is asymptotic analysis? In asymptotic analysis of algorithm, it will done in terms of the input size. So we need to observe that by providing the input to the given algorithm, what is the effect of uh, of the algorithms. So in this, we need two variation of time with input size is calculated, but not the actual running time. So asymptotic notation simply describes a shorthand way to represent the time complexity of the given algorithm. There are three notations: theta notation, big O notations, and omega notations. So theta notation simply shows the average possible time or average case time complexity of the given algorithm. Big O notation simply shows the slowest possible time or worst case time complexity of the given algorithm. Omega notation simply shows the fastest possible time or best case time complexity of the given algorithm. So in this session, we will discuss about the theoretical as well as mathematical background of these notations. So first is theta notation. So theta notation simply shows the tightest upper bound and the tightest lower bound. It means the function is sandwiched between the tightest upper bound and tightest lower bound. It is used to define the average case running time of the given algorithm. This is the mathematical definition of the theta notation. So for a given function f of n, we denote theta of g of n as theta of g of n is equal to f of n, such that there exist positive constants c1 is greater than 0, c2 is greater than 0, and this is the threshold value n naught is greater than 0, such that c1 of g of n is greater than 0 but is less than or equal to f of n, which is also is less than or equal to c2 of g of n for all n is greater than or equal to n naught. So as you can see in the given figure, this is the graph of this theta notation. The mid function f of 1 is sandwiched between two functions c2 of g of n and c1 of g of n, and this n naught shows the threshold value. It means after this threshold value, uh, uh, the condition will be adopted. Now, next notation is big O notation. So it shows the upper bound to the given function. It is used to define the worst case running time of the given algorithm. This is the mathematical definition of the big O notation. For a given function f of n, we denote big O of g of n as big O of g of n is equal to f of n, such that there exists positive constant c is greater than 0 and n naught is greater than 0, such that f of n is always greater than 0, which is less than or equal to c of g of n for all n is greater than n naught. You can see in the given figure c of c of g of n shows the upper bound of the given function, and uh, this n naught is the threshold value. It means after this value, the conditions hold. Last one is omega notation. Omega notation simply shows the lower bound to the given function, and it is used to define the best case running time of the given algorithm. This is the mathematical aspect of the omega notation. For a given function f of n, we denote omega of g of n as omega of g of n is equal to f of n, such that there exists positive constant c is greater than 0 and n naught is greater than 0, such that c of g of n is greater than 0, which is less than or equal to f of n for all n is greater than or equal to n naught. As you can see in the given figure c, the c of g of n shows the lower bound of the given function f of n, and this n naught is the threshold value. It means after this n naught value, the conditions hold. Now, next topic is recurrence relations. So, as you know, in mathematics, we have already studied the recurrence relations. It means it's a recursive definition of the mathematical function or simply a sequence. Let us take an example of t of n is equal to t of n minus 1 plus n, and this is the initial condition. T of 0 is equal to 0 for all n is greater than 0. So there are basically three methods to solve these recurrence equations. First is substitution method, second is recursion tree method, and third is master theorem method. So we will discuss one by one. So in first is substitution method. So in this, use of an initial condition in the initial term and value for the next term is generated, and it is continued until some formula is guessed. So for example, T of n is equal to T of n minus 1 plus n with given initial condition T of 0 is equal to 0. So putting the value of n is equal to 1, 2 and 3. So we will simply find T of 1 is equal to 1, T of 2 is equal to 3 and T of 3 is equal to 6, like this. So we can derive or guess formula as T of n is equal to n into n plus 1 divided by 2. So which is order of n square. So how we will get order of n square? So simply this is the by quadratic equation in terms of n. So by uh, by how we'll get the big O notation? So simply identify the order highest order term with respect to the n. So in this case, it is n square, and ignore the lower order terms in terms of n, and also we need to omit or remove the constant associated with these terms. So definitely we will find the order of n square. So next is the recursion tree method. So it is very important, and it is totally logical and mathematical concepts. So first, let us take an example of the given recurrence relation as T of n is equal to 2Tn by 2 plus C of n. So let us, we need to create the tree of the given recurrence relation. So first we need to start with the T of n. So C of n, this is the root of the given tree, and this C of n is uh, uh, divided into two parts as 2Tn by 2. So it's a T of n by 2 and T of n by 2. This is the left child of the given tree, and T of n by 2 is the right child of the given tree. Again, this is replaced by the C of Cn by 2, C of n by 2. Again, Cn by 2 is breakdown in two childs as T of n by 4, T of n by 4, like that. And we can proceed in similar manner. Then we will we have left we got the uh, complete tree is given in the figure number D. So what we will do in the next part, so we need to calculate the cost as each level of the given tree. So you can see in the diagram, at level 0 the cost is Cn, at level 1 the total cost is C of n, at level 2 the total cost C of n, and at the last level the total cost is C of n. So how we'll get C of n at the last level? The total number of node is n, and each node contributing the C cost. So totally C of n. So next is we need to calculate the height of the given tree. So as you can see in the given tree, the tree is proceed in terms of 1 by 2 order. Like the cost as label 0 is C of n, label 1 is C of n by 2, label 3 is Cn by 4, and label 4 is definitely Cn by 8. So we will find that 1 by 2 uh, it will be increasing by multiplying 1 by 2. So we will find the cost h at height 0 is C of n, at height 1 is C of Cn by 2, at height 2 is Cn by 4. So we need to generalize these terms. So suppose we want to calculate the height uh, at I level. So 1 by 2 to the power I is equal to n. Uh, so by taking the log of the both side, so we definitely get the uh, log of I is equal to 1. Yeah, so we definitely find the I is equal to log of n. So uh, the height of the given tree is log of n. So you can see in the given tree, or you can observe the given tree, the label of the tree is height of the given tree plus 1. Okay, so at label 0 the height of the given tree is 0. At label 1 the height of the given tree is 1. At label 2 uh, at label at level 1 the height of the given tree is 0. At level 1 the height of the at level 2 the height of the given tree is 1. At level 3 the height of the given tree is 2. Means 1 plus height of, level of the tree is equal to 1 plus height of the given tree. So uh, so the cost at the cost at each label is C of n, and the total number of label is log n plus 1. So the total cost of the given tree is simply the uh, C of n into log n plus 1. So definitely we have with C n log n plus C of n. This is the final cost of the given tree. So next is master theorem. So in the master theorem, it is used to solve the recurrence relation of the following form. Suppose the given recurrence relation in the given format as T of n is equal to a t n by b plus f of n, where a is greater than or equal to 1 and b is always greater than 1, and it should be constant, and f of n is a given function. So there are three cases in the master theorem. The case number 1 is if f of n is big O of n to the power log a minus something base b, then the solution of the solution is T of n is theta of n to the log a base b. We simply remove the uh, 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 subtraction part. Okay, so it means the rate of growth at leaves is faster than f. For example, let us take an example of the T of n is equal to 4t n by 2 plus n. So we are comparing with the above equation. So we find a is equal to 4 and b is equal to 2 and f of n is equal to n. So these value put up in the above general equations. So finally we will get the solution as t of n is equal to theta of n square. The case number 2, if f of n is theta of n to the power log a base b, then t of n as theta of n log a to the base b multiplied by the log of n. The rate of growth of leaves as same as a f. For example, let us take an example. T of n is equal to 4t n by 2 plus n square. So uh, uh, we are comparing with the general equation. So uh, we find a is equal to 4, b is equal to 2, and f of n is equal to n of n square. So by comparing the case number 2, we will get the solution as t of n is equal to theta of n square log n. So in the case number 3, if f of n is omega of n to the power log a plus something base b, then the solution will be t of n is theta of f of n. It means f grows faster than the number of leaves. For example, t of n is equal to 4t n by 2 plus n cube. By comparing the general equations, we find a is equal to 4, b is equal to 2, and f of n is equal to n cube. By putting these value in the case number 3, we find we have left with the final solution t of n is equal to theta of n cube. Now I am moving to the next part of my lectures. So one more thing I tell you, what is the growth of the functions? It means growth of functions means by providing the value of the input size. It means n. The value of n, it may be 1 2 3 4 up to the n. So by putting these values in the given functions like logarithmic functions, uh, 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 sequential functions, quadratic functions, cubic functions, uh, logarithmic sequential functions, and exponential function. So by putting the values of 1 2 3 up to the n, so we definitely find the logarithmic function is the lowest increasing functions, and the exponential function is the highest growing function. So next we are focusing on the basic approaches of the algorithm. So there are several approaches of the algorithm, but we will discuss here the three basic approaches of the algorithm. First is divide and conquer approach, second is dynamic programming paradigm, and last one is greedy approach. So in divide and conquer approach, simply the given problems break down into the number of sub problems, and each sub problem solves recursively, and then the solution of each sub problems combine to the generate the solution of the original problems. So there are three steps in the divide and conquer approach. There are several applications of the divide and conquer approach. One of the famous algorithm is a merge sort algorithm, quick sort algorithm, Stresson's matrix multiplication algorithm. It may be some more examples of the divide and conquer approach. Next is dynamic programming paradigm. It is similar to the previous one. It's similar to the divide and conquer approach, but when applies the dynamic programming, when the sub problems overlaps or share the sub problems, and solve each sub problem just once. It means no need to recompute the values again and save the answers in a table. So it means it is memorable in the future. So and this approach is applied to the optimization problems when we need to calculate the maximum or minimum of the given problems. There are several applications of the dynamic programming paradigm. These are the famous algorithm, all pair shortest path problem, traveling cells person problem, matrix chain multiplication problems. There are so many problems which we can solve using the dynamic programming paradigm. Next, we are moving towards the greedy approach. In greedy approach, we take the decision at the moment of time, which is best at the given moment. It does not always yield optimal solution, but for many problems, it may be do. There are several applications of the greedy approach. One of the famous algorithm is minimum spanning tree. In minimum spanning tree, there are two famous algorithm, Kruskal and Prim's algorithm. Single source shortest path problem. There are two famous single source shortest path problem, Dijkstra algorithms and Bellman-Ford algorithms. Also, this is the final or point of the today's lecture. Thanking you. These are my references. The most of the content we have taken from the one of the famous book, Introduction to Algorithm by Thomas H. Corman, which is published by the MIT Press. And some of the content we have already taken from the Horowitz and Sahni books, which is published by the Computer Science Press, New York. And these are the some web and web resources which is very useful to the students. So you can refer these two web or e-resources definitely. So there are three links of the NPTEL course. NPTEL is the portal of the IITs, and second one is the portal of the MIT USA. It's an open courseware which is available. The video lecture as well as the web resources, assignments, and their solutions. All these things available on the given links. So thanking you. If you have any query, any doubt in future, and then you can simply drop an email at my personal email ID as sonkarsk.prof@gmail.com, or you can drop an email at my official email ID as sailendrakumarsonkar@usedvu.ac.in. So thank you very much.